Okay, today we're going to look at writing equations of lines. We've been talking about parallel lines and perpendicular lines and the different angles they create. But today we're just going to look at the actual equations themselves and make sure that we understand when equations are parallel and when they're perpendicular and how do we write those equations. So we're going to start here with our point slope formula. And this back in Algebra 1, but just as a review, we know y minus y1 equals mx minus x1. Okay, so you always have m representing your slope, and you're going to be given a point. And go ahead and remind yourself, slope's going to go there, your x value will go here, and your y value will go there. Okay, we'll look at how to manipulate that equation here in just a little bit. Back in Algebra 1, you learned that if lines are parallel, then their slopes are the same. So we're going to write m, and this is a symbol for parallel, and if slopes are the same, we're going to leave it as m. Just remember that our slopes are the same, they're not going to change when the lines are parallel. And so let's even just go ahead and write that, equal slopes. Okay, but when they're perpendicular, remember we have opposite reciprocals. And what that means is we take our slope, and there's our perpendicular sign that we learned the other day. We're going to flip our slope, that's the reciprocal part, and change the sign. So we would say negative 1 over m. Reciprocal means we flip it, turn it into a fraction and flip it, and then change the sign. So if it's positive, now it's negative, now it's positive. Okay, so let's just kind of review some slope here. And let's determine if, given these lines, are AB and CD parallel, perpendicular, or neither. But we've got to make sure that we remember that slope formula. So somewhere on your notes, I want you to write the slope formula. y2 minus y1 over x2 minus x1. Okay, so let's go over here, and we're going to kind of split this into two parts. So we're going to say this is going to represent one line, this is going to represent the other line. Okay, so let's go ahead and write AB, that's our first line, and let's find our slope. So if you need to, x1, y1, x2, y2, just like we did with the distance and midpoint formula. So let's set this up, y2 minus y1, x2 minus x1, minus a negative becomes a positive. So now we can say 6 minus 3 gives me 3, 2 plus 2 is 4, and we can't simplify that fraction any further. Okay, so let's do the same thing with CD, and then we'll look at their relationship. Same thing here, x1, y1, x2, y2. So y2 minus y1, x2 minus x1. There's that minus negative again, so make it a plus. 3 minus 0 is 3. 3 plus 1 is 4. So we know that both of them have the same slope. Okay, so let's go over here to our chart. The slope of AB was 3/4. The slope of CD was 3/4. And we saw in the table above, if slopes are the same, then lines are parallel. Okay, so all you have to do is find the slopes and compare them. Are they the same? Are they opposite reciprocals? Or are they neither? Now we're going to do the same type question, but instead of giving us points, we're going to take the equation of the line and put it in y equals mx plus b form, our slope-intercept form, and pull the slopes from those and compare them. Okay, so let's take our first equation here, 4x minus 6y equals 12. We want to get y by itself, so we're going to minus 4x from both sides. I'm just going to split that here. So we're at negative 6y equals negative 4x plus 12. Divide both sides by negative 6. So y equals, two negatives make a positive, 4 over 6, x. And then 12 divided by negative 6 gives me negative 2. But we can see there that that slope of 4 over 6 reduces. So I'm going to write y equals 2/3 x minus 2. And I'm going to go up here and I'm going to box in my slope because I need to pull that slope in a minute and compare. And now let's do the next one. So we're going to do the same thing, minus 3x minus 3x. We're going to get y by itself, so 2y equals negative 3x plus 10. Those are not like terms, we cannot combine them. Divide everything by 2. Y equals negative 3 over 2. Doesn't divide, so we leave it as a fraction. 10 divided by 2 gives me 5. 3 over 2 cannot simplify, so we can box that in and say we have both of our slopes. So now we're going to bring both of those slopes and we're going to say 2/3. How does that compare to negative 3 over 2? Well, they're not the same, so parallels out. But we can see that they are opposite reciprocals. They've been flipped and the signs have been changed, so we can say that they are perpendicular. Okay, so that's just taking the slope and comparing. Are they parallel because they're the same slope? Are they perpendicular opposite reciprocals, or are they neither? Now let's jump into actually writing those equations. Given an equation, given a point, write another equation that would be parallel to your given equation. So let's make sure we kind of point out to ourselves that we're working with a parallel line here, which means our slopes have to be the same, okay? Our first goal is to take this equation and let's solve for y just like we did on the last one. So we can just go ahead and start working with it, minus 6x from both sides. So we have 5y equals negative 6x minus 10. Divide both sides by 5. Y equals negative 6 over 5 minus 2. Oops, forgot my x. X minus 2. And again, what do we want to pull from that equation? All we need from that equation is our slope. So we can say if we want the lines to be parallel, then slopes are going to stay the same. So we're going to leave it as negative 6 over 5. Now we're going to bring down that point, negative 10, 9. And this is where what we did at the very beginning with point slope form comes in handy because we have our slope, we have a point. So just to review that equation, y minus y1 equals m x minus x1. We can fill that in. Y minus, our y value from the point is 9. And if you need to go ahead and write x1 and y1 right there just to remind yourself, you can. Instead of the m, we know our slope is negative 6 over 5. X minus, and our x1 is negative 10. Two negatives make a positive. Okay, we want to distribute our slope to both things in the parentheses. So we can see negative 6 over 5 x. And then when we multiply, we're saying negative 6 times 10 is negative 60. Divided by 5 gives me negative 12. And we can bring that left side down. Then all we have to do is add the 9 to get the y by itself. Y equals negative 6/5 x. Negative 12 plus 9 is minus 3. And that is our final equation. We can see that the slopes are the same, so the lines would be parallel. Their y-intercepts would be different, and we could see both equations on the line. Okay, the only difference on this next one is instead of parallel line, now we want a perpendicular line, but our process is the same till we get to the m. So let's bring down that equation. 5x plus 3y equals negative 21. Just like we did before, minus 5x minus 5x. 3y equals negative 5x minus 21. Divide everything by 3. Y equals negative 5/3. Doesn't simplify. And then negative 21 divided by 3 gives me negative 7. Again, the only thing that we need from this equation is our slope. And because we want them to be perpendicular, remember we're going to take our slope and do the opposite reciprocal. So we're going to flip it, and we're going to change the sign, making it positive. So this is the slope we want to use, and then we'll bring down the point that's given. Now we're ready to take those two things and plug them into point slope form. So we have y minus y1, m x minus x1. We know that this is x1, this is y1. So y minus our y1 value is 1 equals our slope, our perpendicular slope of 3/5, x minus -5, two negatives make a positive. So let's go ahead and distribute the 3/5. So y minus 1 equals 3/5 x. 3 times 5 is 15, divided by 5 is 3. And then we can add that 1 over there to get y by itself. Y equals 3/5 x plus 4. And there are our perpendicular lines. So our first equation and our latest equation would be perpendicular if you were to graph them in y equals and plot them on a graph. Same steps every time, just pay attention to if you're looking for a parallel line or a perpendicular line, but the steps will be the same. Okay, let's look at this one. Now the difference here on this one is perpendicular bisector. And we know that bisector means that it cuts it in half. And so we've got to think about a midpoint here. So when you're trying to deal with a perpendicular bisector, here are the steps that you want to take. The first thing you want to do is you want to find the midpoint of the line CD, that given line. And remember that to find midpoint, we'll add our x's, divide by 2, add our y's, divide by 2. Okay, so let's plug that in. Our two x values are -5 and 7. Our two y values are 9 and 5. Okay, so we can continue on. -5 plus 7 is 5. No, it's 2. Divided by 2 gives me 1. 9 plus 5 is 14. Divided by 2 is 7. So our midpoint is 1, 7. That's the point that we're going to use to go to point slope form since we want that perpendicular bisector. We want them to be perpendicular and we want it to go through the middle and bisect line CD. So second step is going to be to find the slope. Okay, we know our slope formula is y2 minus y1 over x2 minus x1. Okay, our y2 value is 5 minus 9, x2, 7, minus -5, so it becomes a plus. So 5 minus 9 is -4. 7 plus 5 is 12. We can see that that reduces down to 1/3. But because we want the perpendicular slope, go ahead and make yourself a note, we have to do the opposite reciprocal. So we're going to flip it and change the sign, which means our slope that we're going to use is 3. So now we're kind of back to where we were on the last two problems, where we have a point, we have our slope. Third step is to go to point slope form. So now we can find our perpendicular bisector. Just writing the formula that we're going to use, just like the last two problems. Okay, so y minus, let me go and change color so it stands out here. Y minus our y value, we're using this as x1, this is y1. So y minus 7 equals m, which is 3, x minus our x value of 1. So nice little problem with no fractions to worry about here. We're going to distribute the 3, y minus 7 equals 3x minus 3. Add the 7 over to both sides. Y equals 3x plus 4. And that would be the perpendicular bisector. If you were to plug in CD into on the graph and graph this new slope, or graph this new equation, you would see that they would go right down the middle and they would create those right angles, making our perpendicular lines. Okay, on the notes, you can skip your group practice today. We will do that as a warm-up together when I get back. So let's now jump to the challenge question. Now, notice in the problem, the reason it's a challenge question is because we were given all the points except for one, and we want to know that they're parallel. So we have to figure out what x is going to be to make line CD and EF parallel, given that same slope. So let's go ahead and make ourselves a note, just to remind ourselves that that symbol right there means parallel. Okay, so we have to think about this line and this line here. We have everything for EF, so let's go ahead and figure out what the slope is of EF, and then we can use that to find x so that we can find the slope for CD. So step 1, EF. We remember that our slope formula is y2 minus y1 over x2 minus x1. Okay? And again, we're only looking at the points for E and F. So y2 is 4 minus negative 6. Nope, not that one. 14, sorry about that. So 4 minus 14. Those are your two y values. And then x2 is negative 2 minus negative 6, which becomes plus 6. So 4 minus 14 is negative 10. Negative 2 plus 6 is positive 4. And that simplifies down to negative 5 over 2. We now know, because the lines are parallel, or we want them to be parallel, that both of them have to have a slope of negative 5 over 2. So we have to figure out what x is going to be so that line CD has the same exact slope. So here's how that works. Go ahead and start setting up your slope for CD. Let's put everything we know. So x2 is negative 4 minus 16. X2 is 2 minus x. Okay, we can go ahead and combine this numerator here. So we know that negative 4 minus 16 is negative 20. And we're just going to leave 2 minus x there. Because we want them to be the same, we're going to set these two equal to each other. So we're going to say negative 5 over 2. Let me change colors here. Equal to negative 20 over 2 minus x. Now, when we did our algebra review, we learned that when we had two fractions and we were trying to solve for x, all we had to do was a cross product. Okay, we just have to cross multiply. So we're going to say 2 times negative 20 and negative 5 times 2 minus x. So 2 times negative 20 is negative 40. Distribute the negative 5, negative 10, plus 5x, since they're both negative. Let's move the 10 over. Negative 30 equals 5x. We divide by 5, and x equals negative 6. And you could easily plug it back in there and see that x, that 2 minus negative 6 would give you 8. And then negative 20 over 8 would simplify the same way. Okay? All right. So remember that lines that are parallel have the same slope. Lines that are perpendicular have opposite reciprocal slopes. Remember, opposite reciprocal just means to flip your fraction and change the sign. Follow all of these instructions and you'll be good to go.